use to make our stuff work. This will be part one. Ideally, we'll have a lot of questions on each thing. So if you don't understand something, don't assume anyone else does either. So just ask. All right, so let's see. All right, can you guys see this?
Yep.
Yes, okay. All right, okay, let's start with Protobuf. Okay, so this is Google's language neutral, platform neutral, extensible mechanism for serializing structured data. All right, so what does that mean? This is basically a way to turn a struct or a class from a programming language into bits and turn those bits back into the struct or class. And so this will allow, and also in doing that, you can go between multiple languages. So for example, you had something in Java, you could send it over the wire into something like C++. So this is what we are using for, I think, all of our communication right now. So let's, okay, any questions on that before we move forward?
Communication from the web to the server.
This doesn't do the communication. This is just the serialization. So you're turning it from an object into bits, right, and then the bits back into an object. Okay. Yeah. Sure. Any other questions?
I won't ask many of these, and sorry to do it. We do not use Protobuf in enterprise. Is there a moral equivalent?
Well, you actually do, and you'll see why in a few minutes.
Oh, okay, fair enough. Thanks.
Okay, so here's an example of Protobuf. So if you look on the far left, this is a definition of a message. So you can see that this is basically a person class with a name, an ID, and an email. And you can see that each of these has a type. So you have a string, you have a 32-bit integer, and you have another string. And it also has a, whether it's a required or optional parameter. One thing that may be a little confusing here are these numbers on the right-hand side. You have 1, 2, and 3. Those are the order of the fields within the class. They're not values. Does that make any sense?
I thought they were initializations, so that makes no sense.
No, they're not. They're the order of the fields in the class. And so, if you go create versions of this and you scramble your numbers, I think it gets unhappy. So just, that's something to be aware of. I think that's the most complicated part of the whole thing. So once you have these proto files, you can then generate your classes in whatever language you're using. So say, for example, you're using Java, you would run a generator program and it would spit out your Java classes. And equivalently, you could spit them out in Go or C++ or whatever. So this next example here is using this person in Java. So you see here it's building a new one, it's populating some values, and then it is writing it out to a file. So nothing super complicated there. And you can see the same thing in C++, except this is reading. So in this example, this would write it out to Java, and then you would have the C++ read that file back in, and you can just access it like any normal class. All right. Any questions on Protobufs before we move forward? All right, so next thing is gRPC. This is Google's language neutral, platform neutral, remote procedure call framework. And this is built on top of Protobuf. So Pete, that's where this comes in. Just Pete, does that make sense?
Yeah. Well, yes, except we don't use gRPC heavily. That was sort of my catalyst. We didn't use gRPC heavily in the enterprise. We use like, that's not the transport layer. Everything's TCP, I think, but
well,
whatever.
No. This is on top of TCP. So the Java serialization in our COM layer, I believe is being changed out for gRPC, and it's somewhere.
Oh yeah, it is being changed out. Yeah, that's the way I understand it as well. This is the new thing for open source, and from what I can tell, all of our prospects love it when I mention it as the thing that we're using. I think enterprise is something different, but again, I'm off topic, so it's fine.
No, you're on topic. Okay, so what gRPC is basically, imagine you have two machines and you'd like them to talk to each other. gRPC creates an interface that the machines can talk over. So let's say you have a server. That server will basically host gRPC functions, which clients can then call. And the arguments to those functions and the return values are Protobuf objects.
So the serialization is inside the Protobuf, like certificates and whatnot for them to communicate?
So the certificates, the gRPC is managing the certificates, but the Protobuf is doing the serialization and deserialization. Okay. Is that clear?
More so.
Okay, so ask some more questions. Well, actually, let me go to the next picture and then we can ask some more questions. Okay, so on the left-hand side here, in this example, it's got a C++ service. Inside that, it creates a gRPC server. Then let's say you have a Ruby client. This has it calls it a gRPC stub here, but that's basically just an interface that Ruby can call, and then it will send a Protobuf message to the C++ server. It will do its computing, and then it will send a Protobuf message back to the Ruby client. And similarly, you can have a Java client doing the same thing at the same time. Any questions here? Or Amanda, is there anything we can clarify?
Thinking. So how does the gRPC stub know to go back to that C++ server, I guess is my question.
So when you set it up, you basically give it an address.
Okay. And it can be not just a local host, but it could be like an IPv6 or?
Yeah, I mean, it's going over a socket.
Okay.
Margaret, are we recording this?
Okay.
All
funny,
right.
I just asked the same question.
Okay.
So if the left were a Java service,
Yep.
Can you just talk me through serialization in light of this picture?
Okay, so let's go 2 slides forward and then come back to it.
Okay.
Okay, so here's an example, and we'll just say this person is a gRPC message, and you'll see that this message looks quite similar to the Protobuf message. So you've got name, ID, some Boolean argument here. You've got the 1, 2, and 3 again. So this is basically within a gRPC configuration. This is how you would define an object. Then let's go 1 step further. And you can see at the top here, we are defining an interface. So here you're creating a function, an RPC function that's called say hello. And say hello takes 1 argument, which is hello request. And we define that right below here. And it then returns a hello reply, which is this other message down here. So we have 2 types. We have the request type and the reply type, and we have 1 function, which is say hello. So if you look at this example here, what you would do is you would define that gRPC file, And then you would say, all right, generate the C++ code. And that would generate the objects and the interfaces. And then you would implement the functions in the interface. And then you would create the server in the C++ code. Then in the Ruby code, you would run your code generator to create the Ruby objects. And then you would write your code that calls the interface to do things with them. And you do the same thing with Android. So Pete, does that clarify what you were asking?
Yes, I think I get it now.
Okay, yeah. So, for things we do, let's say you have the GUI wants to talk to, wants to get table stuff to display. It can talk over gRPC and ask for the chunk of data that it needs, things along those lines. All right. Any other questions before we get out of gRPC?
Do we know anything about why the world's loving gRPC so much, or why the world seems to be centralizing around it for?
It makes life really easy, right? So Protobufs magically takes care of serialization and deserialization. It does it in an extremely efficient way where you're not copying stuff around or doing anything like that. It also, when you send the messages over the wire, they're very small and compact in size. Mm-hmm. And then the gRPC layer adds, the authentication. It also adds, it makes it really easy to add new functions and functionality. So it solves a lot of problems in a very simple way. And it also works with just about every language anyone cares about.
And is there anything we have to think about, or is there anything users ever have to think about, or like the Nate and Collins of the world in regards to the size of that message and how they engineer the use of the interfaces on the client?
Yeah, I mean, you could certainly do stupid things and try to send a terabyte of data, but But
I don't even mean the total size. I mean, each Protobuf is small. Is there a way to make it more? Does that hit the way they think about our specifically architected solution?
Yeah, I mean,
lots of small messages is a thing, right? So
yeah, I mean, this is set up to be really easy. So there are functions you can call that just immediately return. You can also set up, I believe you can set up streaming functions where every time the server has an update, it sends it to the client. Mm-hmm. So you're taking care of both of those use cases.
Okay, and I understand this all in the framework of client-server communications. This may or may not be relevant for server-server communications for Deephaven specifically, right?
It absolutely would.
Okay, so we'll be using it there as well.
I assume all of our communication will go over this. So if you look at our open API libraries, they use this in the background.
Right. So in the future, this might not mean anything to anyone else, but we think, the way I've internalized it is preemptive tables in the open source aren't really a thing. That really it'll be Barrage over gRPC, worker to worker.
Yeah.
Okay.
So one of the reasons why we have two containers for gRPC is for one being the server, and then the other one is the client side to help facilitate the IDE with the server.
I assume that's the case, but I haven't looked at how we have it set up.
Okay.
There is one complexity here that I should point out, and that is with JavaScript. It's kind of a crappy language and is not typed very well. And Mike, I'm being nice here. So anyway,
it's the whipping boy of languages, right? It's just the absolute target.
Yeah. So anyway, with JavaScript and gRPC, it doesn't work like the other languages. You have to actually put a proxy in there to do some magic. And so what is our proxy server? Envoy is our proxy server, and I believe that's what we're using to handle the gRPC JavaScript. I believe there's an update to JavaScript coming eventually, which will fix this and make it behave like the other languages, but it is certainly not there yet.
So if you had two servers, both of which were running like a C++ service, why do you need the interpretation ability, the serialization that Protobuf offers?
Okay, so if you're going to send something from one place to the other, right, you have to turn the something into bits.
At some point, yeah. Okay.
Right,
Sure.
So that's what the serialization's for, right?
So it doesn't care that it's going to the same language. It just has to go into bits and then come out.
Right,
Something
and
else.
it should do it efficiently.
Right. Okay. And it doesn't matter what languages are here.
Right.
Okay.
Yeah, and that's the whole point of this.
Got it.
All right, anything else on gRPC before we charge ahead? No. All right, so let's go to Arrow. Okay, so Arrow, it took me a bit to get my head around what they were targeting, but let me just read this. Defines a language-independent columnar memory format for flat and hierarchical data organized for efficient analytic operations on modern hardwares like CPUs and GPUs. And it targets zero copy reads and serialization and other things. So I'm guessing that means not much to anyone except the guy that wrote it. Okay, so let's look at what Arrow actually is. So Arrow is actually just, so we have file formats, things like CSV or XML or things like that. Arrow is actually just a memory format. So it is a layout of bits in RAM for tables. Okay, so if you look at the picture here, up on the top is a logical view of what a table is. And, but there's no such thing as that in the RAM. You have to put things in different places. So if you look on the left here, this is kind of a traditional row-oriented storage of the table, where one row is stored together, and then the next row is stored together, then the next. And anyway, that kind of sucks for various reasons. So what Arrow says basically is that, let's group all of column 1 together, and then group column 2 together, and then group column 3 together. That way, if you're doing some operations on column 1, then you can just look at column 1, and you're not, your memory is not fragmented. You're operating on memory that is densely packed. Okay, any questions here?
I mean, so to me, this picture is just row versus column, and I get it.
Okay, it's row versus column in RAM.
Right, exactly. So, I mean, to me, so that's, was Arrow really so original in contemplating this, or they just created an easy standard and that was their reason to exist? Because it seems like whatever, column orientation has been a thing for a long time, and it even makes sense to somebody like me why it has value, and oh, it's in RAM, just not on disk. Seems like crazy obvious, but I guess this is just the standard, right?
It's just the standard, yes. Okay.
And the way I think about it is, once you have data in memory like this, hypothetically, there's lots of different applications and languages that can take advantage of this format. Okay,
yeah. So let me get to the purpose. So if you look on the left here, this is kind of the standard way things work. So in a complex application, you may have more than one language or more than one library that needs to do something, and each of those laid out their tables in their own special way. And so every time you go from point A to point B, you have to do some sort of copy and conversion, which is both slow and requires developer effort, which kind of sucks. So the Arrow idea is what's on the right. is that you can get all of your tools using the same in-memory layout for these things, so that you don't have to go through the copying or the conversion or the developer work when you hook A to B or B to F. All right, any questions on Arrow?
It says something about zero memory read.
Yeah, what was that?
I wanted to see that again, yeah.
Zero copy.
Zero copy. It's because it pulls it from the original database. Okay.
Yeah, I mean, so it's trying to minimize the number of times you have to copy and convert and things like that.
So per the picture at bottom right, the way I've always interpreted this, you have some application, it wants to vomit data into the world. It can do that. It now sits in memory and anyone can grab it as it exists without copying it or translating it, so to speak.
Yeah, they can just hand off a reference and that's it.
And for us, one of the things that the development team is considering is having Arrow be the in-memory object that underpins Deephaven. Right now, that is not the case.
Yeah.
You would have to, Deephaven would be one of these things that would be a consumer of an Arrow memory buffer, rather than, that Arrow memory buffer actually being the representation of a Deephaven table that gets worked on by the CPU.
Yeah, and how that would work out, I'm not sure, because right now, we have the idea of column sources and things like that, and tables reference the column sources, and then we have indices because we're doing operations and real-time stuff, and I could see us backing stuff by Arrow, but at the end of the day, do we end up with something that is actually something that could be handed off to another program, or we have so much complexity from other things that we really didn't gain anything? I don't know without seeing some design hashed out.
Yep, I think it is design work for August. Design work, not development work.
Yeah. All right. Anything else on Arrow? All right, let's look at Arrow Flight. So basically this is Arrow plus gRPC. So let's say you have some Arrow table and you want to send it over an RPC call. That's Arrow Flight. And so, I believe we're using this in some of our communication layers, for example, in Barrage. Any questions there? It's fairly simple. All right, Arrow Feather, we are currently not using, but it's something we probably need to support. Did you guys see what JJ had there?
I can read it. One sec. Come on. He says, can you cover gRPC? Oh, can you just give him gRPC again in a couple sentences? He missed it.
So JJ, we're recording this if you want to watch it later. We covered gRPC for quite a bit.
I thought maybe you were going to move on to Barrage just to go a little further back on Arrow Flight. So, Arrow Flight's really pretty central to our pitch because Barrage, Arrow Flight is how we intend to move data between server and client at least. It is the gRPC implementation that we were talking about before, really, is Arrow Flight for our data. Arrow Flight can only handle static data. So we've built an extension, a compatible extension of Arrow Flight that we call Barrage, which uses some fields in Arrow Flight, some open fields to more or less handle all of that dynamics of data. So all of the instructions around remove, update, modify row, add, remove, modify, update rows, so that you can use Arrow Flight in Deephaven and actually get the ticking, updating experience server to, between servers across the network. So,
so Arrow Flight is for static stuff. Barrage is are extension of that to handle ticking tables.
Yeah. And we're hoping, obviously, when, you know, Barrage is its own project, we hope to get a real seat at the table for Aero Flight and to be seen by that community. Obviously, no one else knows how to use Barrage, even once it exists and working. We'll be the only really downstream consumer, but just like Aero can push static data to memory and have lots of things to use it, Aero Flight can do that across the network between lots of applications. We think Barrage hopefully can become the standard where you're doing all that and the data is ticking and changing and updating and is dynamic. And you know, really introduces value, but also our brand to that developer world.
All right. Anything else on Flight? Or okay. So the next case here is Feather, and this is just a case we need to think about on the DevRel side. So Aero is an in-memory format. Flight is a format for persisting that on disk, and so you know, we should want to support reading a Feather file into a Deephaven table. So anyway,
do you know anything that contrasts Feather to Parquet?
So they are different. Feather, they support compression now. They used to not. I think Feather predated Parquet. You know, they are going to have different performance characteristics. So, you know, I think we should do a converter, and then we can just see how they perform differently.
So do these methods already exist in the OSS, or?
No. So, you know, what the code I have here is, you know, just using the PyArrow Python module. And so, you know, there are ways to go through pandas, but going through pandas is slow. So it's something we need to take a look at some point.
So what exists in, you know, we consciously said we want to get something out in April. It was probably May 1st when we did it. We knew what we put out there was mostly the engine without many hookups, where hookups means getting data in, getting data out. The most vital hookup, the first hookup that they're working on now, which we had working in enterprise, but nobody was using it. So working should be used with quotes, was Parquet, right? Which is, I think, the dominant on disk persistent format for columnar data. So, you know, that'll be the first thing. The second thing, that second hookup that's vital to port from enterprise to OSS is Kafka, we believe, because our headline reason to exist is that we're good with real-time data. Real-time data is all about Kafka streams and Kafka events. So those would be the first two. From there, you can imagine the team moving into lots of other things that either we've done before, like ODBC hookups to all the SQL stuff out there, or things we haven't done before, like Feather or important APIs that exist from data publishers or whatever the case might be.
Yeah, and I guess also CSV is one of the first formats that's getting reworked. And I guess my hope is that, you know, when we iterate with the dev team and we get to some kind of standard for what these interfaces look like, then it'll be easier for this team to start from the standard and implement these cases.
Well, and it's really inefficient to go through the data frames, like you said, right? So we want the standard to Deephaven rather than the intermediate. So
I guess by standard, what I mean is a standard interface. So like with CSV, we're going to have methods like read table and write table, and probably some other things. And so you imagine that Feather is going to have the same method names, right? So, you know, it's kind of with the CSV stuff, we'll hammer out the interface and what it looks like. And then as we add new data types, it should be easier to add the next one and the next one and the next one. Right. Anything else on Feather? Okay, Parquet, which Pete brought up a minute ago, is a column-oriented compressed binary file format. So just like we had Arrow being an in-memory data layout, Parquet is an on-disk data layout. And this picture on the left is from the Parquet site for how the files are laid out. I made a simplified version on the right, which I think is easier to understand. So within your file, you have things called chunks. And a chunk is a group of rows. And within the chunk, you store data for each column together. So for example, column A's data would be stored together, and then column B's data would be stored together for each of the columns. And then you would have another chunk for the next group of rows, and another and another. And then at the end of the file, there's a footer that explains what is actually in the file. It explains, chunk sizes and things like that. With a format like this, because it's in binary, it's possible to do things like memory map the file. So instead of, when you access this, reading the whole thing into memory and then doing something with it, you can say, treat the file like it is pages of RAM, and then read it as necessary. And the OS will deal with things like paging in and paging out the pages of RAM. So anyway, you can doing things like that. Your memory usage can be far below what it would be if you had to read the whole file in. Great. Any questions on Parquet here? Parquet also supports compression, so you can end up with smaller files at the end.
I have just two things to say, and they might be obvious or whatever. One, I mean, Parquet is, I think there's lots of different ways to use Parquet. For example, you can have hierarchical structures that naturally get laid out in Parquet. You could think of, we have partitions and groups in our data. You could imagine creating that in Parquet as well. That's just one example. I think there's probably lots of different ways to use Parquet in sophisticated ways, sophisticated use cases. And I think part of what the DevRels group is, this is true of Parquet, it's true of lots of other things as well, is like, how's the world really using this? Like, does the generic easy case cover 85%, or does it only cover 15%? And then we need to handle, sophisticated use case 2 and sophisticated use case 3, because you can imagine that the engine guys need to do stuff to be able to handle those more sophisticated use cases in terms of reading it where it lies. So that's number one. I don't really know all the ways to Parquet, but I mean, Paul Chambray has spent quite a bit of time getting Parquet to work at enterprise with different types of use cases and usage patterns with customers. So I know it's a thing. That's one. Two, the word.
So let me say something on one before you jump on.
Yeah.
So we have a ticket right now where I've documented a large class of the standard ways people do this. And somebody will take that ticket, and when they're doing it, they will write code to generate Parquet and all the different crazy ways people may do it, as well as read it in. And that way we can make sure that we are both able to read what anyone may do, as well as write out stuff that is standardized and existing tools can deal with it.
Excellent. That's great. The second comment related to the word chunk. Chunk might, chunk's probably an overloaded term in the world. We use it as a fundamental concept inside of Deephaven, because instead of, applying operations and methods on records, we apply them on, chunks of records, lots of records at once. This is an architectural, a fundamental architecture that was introduced into the system primarily in 2019. So I just suggest that either the term is overloaded, or it may be that we do cool things like make sure that our chunk and a Parquet chunk are the same things, and we just inherit crazy efficiency by doing so. I do not know whether that is the case, but I would just suggest that, you know, careful of the word chunk, because it might mean a couple of different things.
I was imagining this chunk is a layover from the Hadoop use of the Parquet, right?
Probably, but you know, with something like this, you can imagine that if you have a data that you're incrementally adding to, you can just keep adding new chunks at the end rather than having to store the entire file in memory and then write it out all at once.
So I think that's that was my question, right? That I wanted to ask. Like I'm not. It's not clear to me. Like your sample code, of course, is very brief, and you're just sort of saying, well, I'm going to read a Parquet and I'm going to write a Parquet. But what happens? I mean, I can append to it. Can I delete from it? Can I update stuff inside of it without it moving around a lot? What can I do? Like what's the API?
I think it's mainly one way, but it's been a while since I've looked at it.
Okay. I'm just looking at their docs, and their docs are like, I'm not really sure how to approach them.
Yeah, exactly. They're not tier 1. Yeah, and that's why I didn't include that here. All right. Anything else on Parquet?
Lots, but not right now.
Okay. All right, and then I just threw in kind of an example that's Python, Parquet, Pandas, and Arrow all mixed together. So you can see here it's importing the Parquet stuff from PyArrow, and here it's writing out a table in Parquet format. Sorry, a Pandas data frame in Parquet format, and then it's reading from the Parquet format back into a Pandas I think an Arrow table, which then it's converting into Pandas. So anyway, these things are tied together and convertible between each other. And that's what I've got. Any questions on any of this, or how we're using it, or anything else?
There's just a lot of nuances with this that I'm impressed with, because you don't have to specify indexing or the transposition or anything like that, which is pretty amazing considering some are row-based and column-based. So I really like the behind the scenes of them.
Are we going to be using Parquet in open source at some point?
Yeah. So, Pete, when are we rolling Parquet out? Is it next month?
No, Parquet should be in the release that happens at the end of this month. Think of ingest Parquet, read Parquet where it is, write Parquet. Again, we won't do 100% of every version of what you can do with it, but
right,
read the flat-ish stuff and the maybe first level sophistication of hierarchical stuff we should be able to handle, no problem. And I agree with you, Amanda, that this, like, I think there's a lot of, I'm not expert, I'm like the opposite end of the scale, right? But one of the reasons that I think Python is super popular is people have made it very, very, pretty easy. Like, oh, there's data, I can get data. I'm actually not working on very much data. If I am working on very much data, or a lot of data, I can break it up into bits and farm it out to different places. And the fact that, A, it's not dynamic, and B, if I'm copying it in lots of ways, 90+% of people just don't care about the efficiency of it, right? And it just works, and so be it. I think, we want to, I think we want to do two things. Is one, make sure we are meeting that huge chunk of people where they are, so that they can use all of Deephaven without any seeming, seeming increase in the complexity of what they have to do. And even if they want to continue to use the methods on the screen right now, that it just works, but Deephaven's playing a role backing it. But as we do that, also we want to give them real-time and ticking and updating data, right? Ideally using the exact same methods they're used to, or similar flows, let's say. And two, we want to support the more sophisticated end of this, which are Python developers that care about not doing a lot of copying and not putting slow intermediaries in there. But more importantly, their C++, their Java, their other language developer contemporaries who absolutely would care about it and don't want, all of their data washed through pandas to make it useful for somebody to use, for example. So I said a lot there, but whatever. Make it easy, but also make it awesome.
One of the things that when we're using the pandas, is there like an alias so that when people go to Groovy that nan goes to null and true goes to true and all that other stuff?
Yeah, so JPy deals with the treatment of nulls. And so when we get to that, we can talk about it.
And I don't think, for what it's worth, I don't think we're going to take pandas users and even use the word groovy and get them excited about groovy, right? I think we want pandas users to live in Python, and probably in the short run, we want to make it so that they're comfortable learning some of the syntax they will need to do pandas type of operations in Deephaven. That's probably the truth. Over time, you could imagine in 2022, we deliver an API that's like koalas, that allows them to literally type pandas and just have it run Deephaven, right? So that's what Spark did, so that a pandas user can be using Spark objects and Spark infrastructure in the background, but if their advertising is right, they're actually just typing pandas on the screen and writing pandas related methods, and it just works. So I think we can get there. That's not a 2021 priority though.
Right. Any other questions?
Last thing is koalas is an open source library. So arguably Spark has done quite a bit of work for what we might need to do, or might have done a lot of the work that we need to do that we can just grab.
Right. Any other questions? Margaret, do you have any questions, since you're normally not this far in the weeds? Yeah, the slides are already there. All right.
So one last thing before we all go, I interviewed 3 PR companies yesterday. One of them was my second